Hey everybody, how are we doing? Looking blue today. We're ready to go right here. Let's play some Mega Man music here while we get the camera fixed. How's everyone doing? Can you possibly go over the formula sheet? We did the formula sheet. I'm gonna turn the music down a little bit. We did the formula sheet yesterday. We could do it again. But in yesterday's video, we did the whole formula sheet. So we'll keep taking questions here. I could do the whole formula sheet. We'll take some votes right here. We could take some votes. I'm just getting the camera adjusted. If I broadcast at night during the day, is that Calzone? I thought I saw Calzone in the chat. What up, Adam Richmond? Good to see you here. Good to see everybody. Let's see. I'm never gonna make adjustments to this. I should just stop. I need to stop. I need to never make adjustments. Type 1, Type 2 error, power, and testing. We didn't do that yesterday. Can you go over to how to calculate test statistics? Lots of great questions. Here, let's start it up. Let's get this going. And of course, Bowser here. Yes, Bowser. 37 people. I know, night before the test, and we got 37 people watching. Let's do this. Let's hop into this. Okay, Type 1, Type 2 error. Let's talk about some Type 1, Type 2 error. I'm going to go over here to the side. I'm going to stop. I'm going to stop messing with it. I'm going to stop. Whatever. Here we go. So many questions. If we don't have a printer at home, it's possible. Yep, you can write down the formula sheet. Just make sure to show it. And then we could go back and do the formula sheet. We did it yesterday, so I'm not trying to push people away from this video. But we can start with some Type 1, Type 2 error. We did the whole formula sheet yesterday. We went over the whole formula sheet. I think we're going to do Type 1, Type 2 error to start, and then we can do the formula sheet afterwards. We'll take some votes right here. So let's ask the chat, and we'll have Mubot keep track of some stuff here. So let's do some voting via Mubot right here. Let's do a poll. We got Type 1, Type 2. A lot of people are saying Type 1, Type 2. So let's say what to cover. Okay, tell me what you want me to cover, and we'll do it by way of votes. We have Type 1 and Type 2 will be option 0. We've got here formula sheet. I'm probably going to, even if formula sheet wins out, I'm probably going to do it second. And then what else do people want me to cover? Type 1, Type 2, a lot of those. What else is there? Tools and techniques. I see a tools and techniques. And techniques. Hopefully I spelled that right. What else do we have? What else would anyone want me to cover? Can you remind me what chapters are tomorrow? Tomorrow is chapter 14 through business analytics. Chapter 14 through business analytics. And thank you, Charlie, so much. And power. Can we go over power? Any other topics that people want me to go over right here? We've got a bunch. Can you go over chi-squared stuff? Chi-squared. So let's go there and let's do it. And thank you so much, Charlie. Charlie's putting in there the video from yesterday, and I'll allow multi-voting. What do we need to know about business analytics? So let's put business analytics lecture right here. So here we go. Let's take votes. I'm putting the votes. Oh, I didn't. Here, wait, stop the vote. Start the vote. Sorry, you're about to see Mubot spam the chat here. So Mubot's about to make the voting appear again. So here's what you can cover. Here's what we're going to cover right here. Is it max vote 1? Should put more votes on it. So the options are Type 1, Type 2 error, the formula sheet, tools and techniques, power, chi-squared, or business analytics. And the way you vote is you go ! vote, and then you type the thing you want us to cover. So vote now, and as people are doing it now, so just kind of pause on that screen right there, and I'm going to look at the votes, and then we'll go by that. I will do the formula sheet if it's like one of the higher options. We won't do it first here, but vote on what you want me to cover. Tools and techniques is winning out right now as one of them. But whatever has the most votes. So we're going to start with some tools and techniques. That's leading the way right now. We might do some Type 1, Type 2 next. But vote on what you want to win right here. So be voting on it. Make sure to do a space between what you want. So as you see people doing ! vote and then the option, make sure there's a space though. So make sure, and you can only vote once, I think. So the way you see like Christian right there just voted on the formula sheet. So Delaney right there voted on tools and techniques. So let's start with some tools and techniques questions. Let's do it. Okay, how to ace tools and techniques. Okay, let's talk about how to ace these questions. Let's do some Cliff Notes type review, and keep voting if you haven't. Scroll up to see what the votes are. I'm just gonna keep it going a little bit longer, but let's do how to ace tools and techniques. 1, first off, have a general knowledge on what we use everything for. So have a general knowledge. Now, this is probably one of the hardest things to do, and I wouldn't, like, I guess we could, like, here, let's go right here. Let's try to do a general knowledge on graphics to start. So with graphics, what do we have for graphics to start? When it comes to graphics, we have categorical graphics, quantitative graphics, bivariate categorical, bivariate quantitative. So let's go right here and start making a list, and let's go categorical. And with categorical graphics, what are some of our categorical graphics? I need your guys' help right here. What are some categorical graphics? What are some categorical graphics that we use? So with graphics, because our general knowledge, what are categorical graphics? Bar chart, pie chart. And let's put something right here. Let's go univariate. Because someone did put mosaic, and you are correct with mosaic plot. Mosaic plot is a correct option. Pie chart, mosaic plot. Brian Making's list, checking it twice. You bet. Twas the night before Stat 201. Thought it'd be a little bit fun right there. Ring chart. I don't like ring charts, but they do exist. Great answer right there, Zachary. I'm just not a big fan of ring charts. I'm just thinking of ring pops. So I do like ring pops, though. Those are good. So overrated, but still good. And those are our main ones. We could also put here frequency table. I don't think I usually put that. And then let's go here, quantitative univariate. What do we have? Quantitative univariate. What do we have? Quantitative univariate. So we need some quantitative univariate now. So what do we have? Quantitative univariate. Histogram. And if I forget something, just tell me. Box plot and stem and leaf. And that's really the main crux of it. Nice job, Andrew, right there, and Charlie and everyone. Linear regression, when we start to get to quantitative bivariate, and let's go here, let's grab this one and put categorical bivariate. So this one is going to be a mosaic plot. If I knew how to spell, I still don't know how to spell. Mosaic plot, contingency table, and by univariate means one variable. Great question right there, Marissa. It means one variable, and great job helping out right there, Tyler and Michaela right there. It means one variable. So you only have one question here. This is like, what is your hair color? What color is your shirt? What TV show is on your shirt? All those would be one categorical question. When we talk about quantitative, one quantitative question would be like, how tall are you? How much is your GPA? How many years old are you? And bivariate categorical is going to be like, what state were you born in? What's your favorite ice cream flavor? I don't know why I keep talking about that one. This is like my key example these days, but that'll make a mosaic plot or a contingency table. If we're not very good at the math portion of the material, what do you suggest we do to best prepare? Know the formula sheet, Eleni. Great question right there. Know the formula sheet. We can do that. We can maybe do a quicker review of it today. We did it yesterday too, though. We did the formula sheet yesterday, so that's why that video, we go over great detail, the whole formula sheet yesterday. So know your formula sheet. Some of it, the mathy stuff, is a lot of plug and chug, put the numbers in, solve the equation, and you're good to go. Bivariate quantitative, what do we have here? Bivariate quantitative, what do we have here? Any ideas? Regression. Regression, QQ straight enough, no outliers, scatter plots, and correlation. It's only got one. Oh, it's got two. I never know how to spell. So regression, scatter plot, correlation. I guess technically, if we're just talking about the graphic, we're just talking about a scatter plot. Now, these are the graphics you would use right here. These are the graphics, and these are kind of the key graphics. I didn't cover everything. This is kind of a general knowledge right here. It's a really good help to kind of know. And this is just good stats knowledge, like a good kind of general toolbox you should have on the graphics. But now let's go to this. Let's change the name of the game. And let's do this. Let's go to tests. So we're going to do the same thing right here and go to tests. Now, I should add in one more category here and put in category. Let's go quantitative / categorical. And what I mean by this is the Y is quantitative and the X is categorical. So what do we have here before we talk about the tests? What kind of graphic would we make? And here, I'll draw it out for everybody real quick. What kind of graphic would we make for this right here? There's a few answers. There's two I can think of off the top of my head. But here's the graphics we would make for these. So you are correct, clarified. You are correct on the test. Great work. That is the test right there. So this is the two-sample t-test. When we do this right here, and you're noticing, so we do have histograms. So the two answers wouldn't be a singular histogram or a singular box plot. So you notice here with one quantitative variable, it's a histogram or a box plot. With a two-level, at least a two-level, we would get what? We're not going to get one histogram or one box plot. What we're going to get is stacked histograms. So that's what you saw me draw a moment ago. Stacked histograms and side-by-side box plots. So stacked histograms and side-by-side box plots right there. And that's what I did little drawings of. So now we go down here and we do the tests. And let's kind of delete what we have and then think about this. So when we do univariate categorical data, with univariate categorical data, what is a question we could ask? With univariate categorical data, what is a question we could ask? Like univariate categorical data, what is a question we could ask? What is a question we could ask? This is just the more you can, what's your hair color? Perfect job right there. And then we say, you know, brown hair. So we could ask the proportion of people who have brown hair. So what kind of test does this sound like to you? The proportion of people who have Taco Bell. Yes, every question is Taco Bell. People know that about me. Why is the lighting changing? It's magic color change. So what is this sounding like? Ooh, careful, Charlie. You're so close. You are it is kind of a z-test. One little thing, the proportion should be mentioned. This is a one proportion z-test. So remember, Mr. T is mean. I'm sure he's a really nice guy. I'm sorry, Mr. T. Every time I say that, I always apologize, Mr. T. But why do we say Mr. T is mean? Because that's for the quantitative data, for the quantitative when we're dealing with the mean. So this is a one proportion z-test. And then, so we go to right here, and remember Mr. T, quantitative, mean. Mr. T is mean. So what do we have right here? What is this called? And we only have one variable right now. We only have one variable. We only have one variable that we're dealing with. So this is just a what? T-test. That's all it is. You can call it like a one sample T-test. It's perfectly fine to call it that, but it's just the T-test. It's just a T-test. So now we have what we're dealing with univariate quantitative variables, and now we have categorical data, bivariate. So this is two categorical variables, which makes count data. Nice job right there, Logan. So we have the chi-squared, which has the fourth condition. We did conditions yesterday too. Chi-squared test of independence. And this is one of the fun ones where we see if they're independent of each other. There we go. Ooh, there we go. Better. So now we have quantitative, which is bivariate quantitative. So what do we have right here? This one everyone knows. Hey, Kobe, good to see you here tonight. What do we have with quantitative bivariate, regression / correlation? They're both kind of built off each other. And then last but not least, we have a two-level categorical variable. And so let's make this kind of a note right here. Let's put a note and say two-level. So two-level, two-sample t-test, exactly. So two-sample t-test. So this right here is like the literal cheat sheet for most of the questions. We should maybe put decision tree right here. Can handle everything but identifiers. And this is just going to be kind of the thing that can handle. And let's put a note next to it. Let's go here. Not do underline anymore. That looks insane. So let's say works well with lots of variables. Okay. Decision trees are something you generally use. They won't be on the finals like interpreting them, but knowing when to use it. Like a decision tree question would read something like, UT wants to understand why students are passing a certain class. They collect 40 variables and want to figure out what relationships the 40 variables have with students passing a class. So as everyone see right here, we have a Y variable of interest. So then we're going to put in a bunch of X variables and try to figure out what the relationships are with those X variables. So decision trees kind of handle a mass amount of variables. So that's how a decision tree question would be written right there. Quick question, is test 3 review a good play? Oh, definitely. Yep. The test 3 review playlist, and I've been plugging that a lot. Thank you, Charles, for asking that. The test 3 review playlist, I've made some really focused videos on it for, let me see right here. Oh, there's the live stream. Go view your own live stream. Here, I'm going to hear myself twice now. 97. Holy mackerel. Wow. Keep asking those questions. And then we're going to write some practice questions right now. But if you're looking for a really good playlist, the playlist I would suggest right now, so I'm going to drop this in the chat. Practice test 3 playlist. I would start near the end of it and I would go over the hypothesis testing part of it. So I'm gonna drop this right here and do that right there. This is not covering, so Jackson, really good question. We're not gonna give decision tree type questions. What we're gonna do is we're gonna give questions to see if you know when to use a decision tree. So the decision tree questions on this won't be like interpreted decision tree. the question would be something like this. So let's do some of these example questions. About how many tools and technique questions should we expect? I think there's about three or four, I think. Do you think there will be a curve? We'll look at the final grades, and if they're like an 80, no curve, and if they're like a 60, definitely curve. So we'll definitely kind of we will kind of go with what the grades are and look by that. So if we think it's a fair test and it accurately grades students, then we will keep the grades. So I don't know what to hope for. So I think it's a pretty good test, but we'll definitely kind of look at it. We're not going to give a test that's too hard and everyone's going to fail it. So don't worry. It will be a fair test, but just make sure your knowledge is there. So let's do some example questions here. Are you ready? So see if you can answer this. So maybe don't look at the chat because the chat's going to be probably saying answers. So kind of don't look at the chat for a moment because I want to see who gets it. So I won't say the answer until I write some possible choices. UT wants to study whether or not students have ever, I don't know, what do you say? Let's see. Have ever, what should they do? They're going to study if UT students have ever done what? Have ever gone to West Town Mall. We're totally lame right here. Tyler. Oh, nice start there, Charles. You're so awesome. Thank you, Charles, dropping the links for us right here. Ever cheated? Oh my gosh. Whether or not students have ever cheated. National reports suggest that 40% of students at university have cheated at some point. UT talks to graduating seniors to see if this is true for our students. What test will they use? Willem they use? So I see some, keep answering in the chat, see if you can get it. Let's go here with t-test, chi-squared, one prop, and regression. What does everyone think? Let's see some votes in the chat right now. We're not voting, but let's see what you think. And I'm going to end the voting on it. Well, let me bring up the vote again. I'll bring up, once we finish tools and techniques, I'll bring up the vote again. We'll see if it weighs in another direction. Nice job. How did you identify this immediately? How are people getting this just like instantaneously and they know, okay, boom. Like everyone is getting this instantaneously. Bonus points if you can identify what that is in notation. There we go. Can we do some betting today? Oh, we should do betting. We'll do some betting here in a moment. I'll do a bet on the next one. We'll do bets on the next one. So because it's one categorical variable, great job with all these answers right here. And who knows, Charlie, you do have the null correct. That it's not technically P, this is P naught. But you will write out for this question that the null is that P is equal to 0.40. So you might say, well, isn't that then P? Well, it's what we assume P is equal to. That is the hypothesized true proportion. So we are hypothesizing for our students that the true proportion. Now, what would the alternative be? And great job, P naught. I just want to say P naught tonight. So what would the alternative hypothesis have as the sign? Everyone should know the trick for the alternative. Whenever you write the alternative, you just change one thing. So you only change one thing. What would the alternative be? You're only going to change one thing. What would the alternative be? They're seeing whether or not this is true for our students. So what would the alternative be? Bingo. Nice job, Sam. Excellent work, Sam. It'd be not equal to because it gives no preference. So because it gives no preference, it'd be not equal to. So great job. The answer was 1 proportion z-test. And there we go. So let's do another one right here. We can keep it the same. I could try to trick everyone to do the same. Let's remove out the 1 proportion because we already did that one. So let's change out the options right here. We'll do some betting. Here, I got to stop MuBot. MuBot is going to tell us that tools and techniques won out. And then people want power next and type 1, type 2 error. So we're going to stop the right there. We're going to stop the voting. And we'll see that the winner was the tools and techniques. Let's do a few more tools and techniques here. And let's change out 1 prop. And we need 2 sample now. Okay. So now we got a 2 sample t-test in here. Can we send it some high max betting? Sure, why not? Let's put the betting to 10,000 points and pay out 100%. Be very careful. This is some high betting right here. Thank you so much, Nikki. Let's go right here. We got a different thing. UT wants to see if their students have a higher IQ than Florida students. Sorry, Florida students. They run a test with 100 students at both schools. UT students have an IQ of 150. Yes, really. Florida has the average of 100. The standard deviations were 15, 10 respectively. And that's just, UT has more of a spread to its distribution. Florida has a tighter distribution. Okay, we'll be nice to Florida. We'll be nice. There you go, Florida. And sure. And I think that's got it. I think that's all the information we need. And yeah, I think people are getting it. Well, let's do some betting. They're a little above average, a little above average. That's good. So which answer? See, I made it too easy. People are... So betting is beginning. Oh, do not bet. Remove all. Okay. Do not bet on option 0. Do not bet on option 0. I just hate that it puts an option 0. I wish it was starting at 1. So take a moment to bet right here. How did the extra credit points we've gotten through semester get added to the grade? At the very end, I add up to 2 points on your final grade. The way clickers work for other classes, they get points on their test 3, and we do it by the bonus right here, by the ones that people again. Make sure to do bet, exclamation mark bet, so you can see Ian did it right there. So Ian's really the only, Matthew's done it right, Catherine's doing it right. So it should be bet, exclamation mark bet, the ID, and then the points you want to bet on it. So you can see everyone betting right there. And there we go. And I'm trying to make some custom commands. I'm learning how to, it's in C# and Python 2 point something. Been learning more about that lately. Trying to learn more coding. Coding's power. So what do we got going on right here? We have a 2-sample t-test. I shouldn't have done the one I just added in, but this is a 2-sample t-test. What do we mean by a 2? What does the 2 of the 2 sample mean? Someone in the chat talk to me here. What does the 2 of the 2 sample mean? Why is it a 2-sample t-test? What the heck is this 2-sample t? What does it mean to be a 2-sample t? Well, not really 2 quantitative variables. There's only one quantitative variable we're analyzing, but because 2 groups. There we go, Gia right there. Nice job, Gia. We're comparing 2 independent groups, and that's one of the assumptions of the 2-sample t-test. Unless you do, there's a way to do it with dependent groups, but we don't do that in this class. So a quantitative variable and a categorical variable, and Delaney, you're right there. It has a 2-level categorical variable. So you can see the 2-level categorical would be what school do you go to, and the quantitative variable is going to be what is your IQ. So great job, UT. Excellent work. Who can identify any of the notation we have right here? Who can identify any of the notation? So we're kind of doing a little bit of notation practice right now, but take a moment, pause on the screen, see if you can do it. Tyler, you're basically right. Everyone's saying n is 100, but not really. Be careful. We have a 2-sample t. So here's a hint why it's not n equals 100. So you're kind of right there. Wait, I'm seeing there. Charlie's getting some stuff right there. So this would be n1 and n2. And this would be s1, s2. And this would be y bar 1 because it's sample mean. So it's a y bar. It's not a mu because it's sample mean. And that's y bar 2. So make sure, and then you could say total n is 200, but usually we don't use that in the formulas. So we have to have the sample size for both groups, and we can see that in the formula right here for doing the 2-sample t-test, that the t with the degrees of freedom is y bar 1 minus y bar 2, which is just the difference, over the square root of the standard deviation 1 squared over n1 plus the standard deviation 2 squared over the sample size 2. Would you also saying mu1 minus mu2 instead of y hat be accurate? No, and so we can't use mu1 and mu2 because that's what we're trying to understand. So is the betting for extra credit? Yeah, it's somewhat, yeah. And then everyone I think who has enough, like we basically have a lot of max extra credit getters, but yeah, that's the way we do extra credit in the class is with so just look at all those points. There's some crazy extra credit going on right now. Tyler, insanity, absolute insanity. Mubot is here, everybody. Say hey to Mubot in the chat. Mubot is here, just chilling out. Who knows what Mubot is going to say? Everyone's checking out their points right now. What's Mubot got to say tonight? Mubot, you there? Can I bet 5 million? Mubot's real name is Andrew. I did not know that, Mubot. Very interesting, Mubot. Next question here. Let's do one more tools and techniques. So we should be able to figure out, let's not even put, I'd love it if someone could put, would a two-sample t-test be quantitative bivariate? What would be quantitative bivariate? How would I write a question to be quantitative bivariate? So a two-sample t-test is going to have a categorical variable, like what school do you go to? So this is going to be what school, so this is categorical. And then the other variable is quantitative. So a two-sample t-test will have a two-level categorical variable as the x, and then it'll have a quantitative y. And Nikki's saying regression. Great job, Nikki. And so a question like that would be regression, would be something like, does studying really help your grade? You have 20 tests this semester. For all the tests, you record how many minutes you study, hopefully it's a lot, and your grade. What tests could you run to investigate this relationship? And is that right? Sure. So this one would be a regression question right here, because we should identify pretty quickly that you record how many minutes and your grade. So you have a quantitative variable here and you have a quantitative variable here. So understanding the variable types is pretty key. And then it could say, you know, like, what graphic would you use to display this? So what graphic would you use to display this right here? I won't put any choices. Can anyone tell me what graphic? And Marissa's right, it would be a regression for the last one. This would be a regression. And then what graphic would you use to display this? What graphic would you use? What graphic would you use? Scatter plots. Scatter plots. And so, Wyatt. Love it, Wyatt. And so we would use scatter plots for this. That is very, 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 very accurate. Should we do one more tools and techniques? Grade as in GPA. I would read that. I would have thought letter grade. Oh, and yeah, so if it was letter grade, that would drastically change it. Yeah, we could say like score on the test. And you study and your grade, you could say score on the test. Hopefully, please tell us if you think there's any confusion. So like we could say score on the test. So let's do one more tools and techniques. I'm not going to give the answer to this one. I'm not going to give any choices. Let's see if we got to that point. So let's say Kroger collects data on their customers to better understand why people buy, let's say, expensive cheese. Kroger uses their full data set of 20 variables. What technique would be best for Kroger to analyze this data? Let's see what people are saying in the chat. What technique would be best? So whether or not people buy cheese is a categorical variable. Yep. This is going to be a decision tree. This would be a decision tree right here. This is like, you've got a lot of data. So you're dealing with like multiple X's. And so you kind of see this kind of clue for the decision tree, especially with lots of variables. Now we could say, we could change the question from a decision tree. So right now the answer would be decision tree. And let's put right here some reasoning. Decision tree, lots of X variables explaining a Y. So that's kind of the clue right there for decision trees, lots of X variables explaining a Y. On the exam, would these questions be multiple choice? A lot of multiple choice. Yeah, we're not going to do it. If we have people write things in, then that's it's not nearly as fun. Lots of multiple choice. And let's change it slightly right here. And let's say Kroger believes it is connected to whether or not people buy expensive wine. Two questions. So is every stats question on the test going to be related to... Oh, yeah. Maybe, Sam. I don't know. That's a good question. No, probably not. Probably not. People are, and Hannah, Tyler, and Rocky Top are getting it right there. Oh, they're saying on the exam with these... Yeah, then we got Rocky Top's question. Chi-squared. Yep, this is the chi-squared. And how did we identify this? Whether or not people buy an expensive cheese and whether or not people buy an expensive wine or what kind of variables. Categorical. So this is bivariate categorical. And then, yep, can anyone write the null hypothesis for this? Can anyone write the null hypothesis for this? We're just like doing all the questions we can. So can anyone write the null hypothesis? Let's do it this. Can you write out the full null hypothesis? What is the null hypothesis for this one? And then we're going to switch topics. So, buying expensive cheese. So, buying expensive cheese is independent of buying... Oh, no. And then I shouldn't have copied it yet. Because now we're just going to go here. We're going to decrease font a little bit. I always like it to be on the same thing. And then we're going to go there. And then we put not. And we've got it. All we say is that X is independent of Y. X is not independent. Brian just got back from basketball game. What all did I miss? We're going over tools and techniques, Dan. Good to see you here. And good luck. I hope your basketball game went all right. And then I'm horrible at basketball. Calzone Tyrone. Yes. Fan favorite Calzone Tyrone is here. Love it. Stat Nation Hero of Eternity, Calzone. So good to see you here. It is finals. Calzone competed in one of our first Kahoots. Hero of Eternity. Why not, Calzone? We need probably a level even higher. The points have just went absolutely nuts. You got a lot of good company now. Lots of good company. So love it. We absolutely love it. So let's do the next question. I thought me and Vic had high points. Yeah, I know. He is a legend among the class. He's one of our during our first Kahoot, he appeared and played in the Kahoot. People sent him the code. I can't remember how they got it to him. Did they like Insta it to you, like something? You're gonna be Thanos at some point. That is awesome. I love it. You're the fan favorite. Next on the docket, we have power. So let's see right here. I'm gonna open back up the voting. So if you want to re-vote again real quick, yeah, no, it was more than a year ago. It'd be a year and 3 months ago because it was for test 1 in fall in 2019. So yeah, craziness. So vote now. I think, yep, we're still getting votes in. So good to have you here. I love it. We just did tools and techniques question. I know time does fly. I think you said you're graduating. Congratulations if so. Congratulations. And we've had random people swing by. I love it. I like it. Like when like Calzone, you're always welcome here. So it's pretty tied up right now. Business analytics is winning out. Vote now for hold your peace, and we are accepting multiple votes. Okay, business analytics is winning out right now, so I'll stop the voting again here in a moment. But business analytics is in the lead, so let's do Calzone's. I love it. Calzone wants to hear some type 1, type 2 error. We will be doing that here soon. So I think we got time tonight to do some type 1, type 2 error. So let's go ahead. Business analytics is winning out, and you know what I might do? Class is over. No, I'm just kidding. Let me pull up the business analytics lecture and kind of give a good overview of it, because that's going to be the easiest thing for me to do. So let me go grab the business analytics slide. I need something better in the background, like Pong, just like something playing in the background. Like, okay, here we go. Okay, let's do this. Okay. Kind of a quick overview of business analytics. Okay. And okay, so let's stop the voting. Stop all the voting. Okay. And let's bring back up the slides. Let's go over here. You know what we might do? We got time for a speed run. Let's do a speed run of it. Let's do a speed run right here. Let's pull this here. Okay, speed run is not going to be set up, but let's go over to it. Let's do it. Speed run. Okay, so I need to orient this screen for it. I don't have this screen to the proper sizing. Can I get it to look right? Sure. Is that going to be good enough? How does that? That's good enough. 30. Pff. It's going to take me more than 30 seconds. It's going to take me more than 30 seconds here. Okay, let's do this. Let's talk about some business analytics right here. Start the clock. Okay, when it comes to business analytics, 45 seconds. So business analytics is descriptive, predictive, and prescriptive analytics. So what do we mean by descriptive analytics? Think about how far does someone hit a baseball? What do we mean about predictive analytics? Think about, will someone be successful in Major League? What about prescriptive analytics? Think about, should we draft this person on our team? Descriptive analytics just describe what is going on, like how far did someone hit the ball? Predictive analytics make predictions about the future. How well would this player do in the majors? Prescriptive analytics, think about a prescription. They give you a course of action, like, should we hire this person for our team? So maybe just put this on a flashcard, like descriptive, predictive, prescriptive analytics. I wouldn't know too much in depth, but that, kind of helps you out right there. Thank you. Oh, no. Thank you so much, Dan. I appreciate that. And we have a bunch of people using analytics right here. Some really awesome stuff goes on. When you think about like Amazon with their recommendations they make you, American Express with questionable transactions. We talked about type 1, type 2 error in the major lecture going over that. We'll do some type 1, type 2 error soon. And Kroger's a really big one, and we'll see some stuff there. Jobs, we just got the new numbers. Our master's candidates. Yep, this is for 201. It's 201. Our master's candidates, I think, have a salary of, I think, $84,000, but do not do something because of money. I kept reiterating that because in the lecture, like, don't do it. This will be a lot of like true, false, maybe some multiple choice, but not too in depth. If you notice, I'm not going into like great detail on this. This is Mary Lightnaker's book right here. This is one of the books I used. The Power of Statistical Thinking, I think it is, by Mary Lightnaker. Really good book. It might have touched Brad Pitt. You never know. So if you buy that book, you might have bought a book from Moneyball. Yep. And so Moneyball really is a movie about, so this is kind of key right here. At least mentioning Moneyball is really key, that in Moneyball, it was Paul de Podesta who really, this is Paul de Podesta right here. And that's, what is it, Peter Brand? No. Remind me of this guy's name. Because Paul de Podesta is who Jonah Hill plays, he's the stats guy, he's the guy I care about. No, Billy Bean? Is that his name? Billy Bean, that's it right there. So I'm on it, yeah. Billy Bean is Brad Pitt's character, and then Paul de Podesta is the other guy. And Paul de Podesta was the stats guy. And so they started to realize, they came up with a formula basically, and what were they using? They were drafting players. So what were they doing? Were they doing descriptive, predictive, or prescriptive analytics? And it's kind of a trick question there because I'm kind of doing all three. But they were drafting players. So which of these were they doing? Were they doing descriptive, predictive, or prescriptive analytics by drafting players? Exactly. Well, got a little bit more prescriptive. They were doing prescriptive. They were choosing a course of action. They might have also, they're also going to predict how well a player is going to do in the majors, but they're going to prescribe a course of action. They're going to say, draft this player. See, like, what products should we be offering? That's a prescription for what we should do. So prescriptive analytics prescribe a course of action. And predictive just predicts the future, and descriptive just describes what's going on. So you can describe, predict, or describe, predict, or prescribe an action right there. Like, think of a prescription, like when you get a prescription from the doctor or something like that. It's here's what you should do. Here's the course of action we're going to take. And so they really revolutionized what's going on. I want to say this also. Now, why in the following years did they not have as much success with what they were doing? Why in the following years, with the analytical tools they started to use, with the Oakland A's, I think it was, why did they not have as much success going into the future? Why didn't they just dominate with what they were doing because they did so well? Other teams, that's exactly it, Steven right there, because other teams started to do it too. You see immediately other teams are like, wait, what's going on right here? And, if Julio swings by, and I don't know if Julio's lurking in the chat, but he's told me, like, it's very analytical in baseball. He's like, everything is about the analytics. Everything is about the numbers and being able to like track people's numbers and look at the numbers and make data-driven decisions. It's all about like, and I think another one of my students just got hired. Congratulations to one of my students, just got hired by the Texas Rangers. So he's going to go off and work for a Major League Baseball team, and I'll have to ask him what he's doing because it might be analytics related. Probably is, because he's one of my analytics students. So great job. I don't know if I say something, but yeah, I'm really proud of him right there. He just told me about that, and we're going to say hey, and I'm going to tell him congratulations again. But yeah, so Moneyball, baseball and statistics. So this is kind of their change to models. We talked about that a little bit. Last but not least, we have a famous story right here dealing with what store. What store? We're not on that slide yet. There's the store. So we have a famous story right here dealing with Target, where Target knew that a teenage girl was pregnant before her family knew. Basically, they sent coupons for baby supplies to the teenager, And then the father was like, what the heck is this? And he went to Target and he's like, what are you doing? And they're like, whoa, sir, we're sorry. We didn't know. I mean, our analytics people think they know, but that was on Vsauce. Yeah. And Stephen Colbert. Oh, I haven't seen the Vsauce one. I'll check that out. They hit the target. You got to watch the Stephen Colbert one. I used to play it, and I played it on YouTube one time, and then Viacom hit me with a copyright ID on it. So I've learned my lesson about playing Comedy Central stuff on my YouTube channel. Don't do it. Viacom doesn't care that we're education. But once again, they knew that a teenage girl was pregnant before the father knew. Then they started mixing up coupons in there so that people would be like, oh, they don't really know. They're just sending us coupons for this. Isn't BA your major or something? Yep. Business analytics is my master's degree. My undergrad is psychology. So I got a psych under degree. And our graduate students are doing really well. Please, 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 once again, this is just something, if you're interested in it, let us know. I'm always happy to talk to people about this. This is not a hard sell on business analytics. It's just, we want people to see how business analytics is being used. And you got companies like Pilot, like you can see our long list of companies that have hired people. You got Pilot, Home Depot, 3M, Disney. We've talked a lot about how Disney has used business analytics. You talk about the Disney Magic Bands. Disney is so analytical. People in the chat are like, yes, Disney is massively analytical. I have students who have worked for Disney too, and they're like, oh, everything they do is analytics decisions. They're analytics at Disney. So you know what people will do. And yep. So you first went over this. I'm contemplating. Yeah. And yeah, let me know. I've had a lot of my students go on to their master's. One student even met her husband in the master's program. She was in nursing and switched over. My mom does that, and if you like that kind of stuff, it can be incredibly, yeah, exactly. So what does your mom do, Marissa? Did you mention this before? Like, if you want to say, you don't have to be too specific, but we'll hop back to the next topic, which I think is type 1, type 2 error. But basically, if you like, I think of business analytics as problem solving. Like it's dealing with data and solving problems and then turning it into actionable decisions. So when you business analytics, she's also what? Marissa, where's she? Send me, I don't know if you want to say it all in the chat, but you have to tell me where she's a stat professor at. That's really cool. That's really cool. Awesome. Yeah. Well, cool. But hopefully she's like, your stat professor did a good job. So how can business analytics relate to computer science? So computer science, so just real quick, we'll go to the 10-minute mark and then I'll switch topics. When it comes to, that's so cool at Alabama. I love stats, if you can't tell. My dad's a statistician. It's kind of how I got into it a little bit. So great question right there about how does it relate to computer science? Computer science is going to be more the kind of in-depth coding, and computer science focuses more on, like actually just getting code to run, to like the end product of getting code to run. But where business analytics is going to be very different is we use coding more to kind of achieve a communication to the business. We're not so much interested in the code because we don't really show them the code ever. And we don't you can create programs, like you can create dashboards. Dashboards with Power BI are really big, with Tableau are really big for those who know Power BI and Tableau. So you're looking more for the user end product with business analytics and the communication of the result, where computer programming, you're not really dealing with the clients as much, I would say. I take everything I say about computer programming or computer science with a grain of salt, because I am not a computer scientist, and someone could hop in here and say, Brian, that is nothing like what computer scientists do. But I always think of it as more in-depth coding, more of a focus on coding, where we just use coding when we need it. Some business analytics people never code. And we do have courses in the program where you don't code, but we do want our students to have some coding skills. And we've been told that by employers that they're really impressed with our students, that they come out with a pretty good, strong knowledge of coding. One last quick story on that too. I had a student last summer, actually a year and a half ago now, who she went through our business analytics 320 and 474, and then she was better at coding than this guy who had been coding for like a year, and he'd been trying to self-teach himself, but she had been coding for like 1 month, and she was like, yeah, he doesn't know how to do this, 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 and this, and I was showing him this. And so I'm really proud of how our program kind of pushes students. She was kind of in an accelerator, I guess, for 2 months, because she went through both. Actually, low-key just applied to Target a couple days. Yeah, and Target's great for internships. Target, I think, are they up in Minnesota too? Target's a really great company and great internships. So good luck right there, Tyler. Excellent work. And we're approaching our 10-minute mark on this. I think we're going to switch over to type 1, type 2 error. Let's hop back over to the main screen. Right under 10 minutes here. I hope you get it too, Tyler. That's really awesome. One of my students got an internship with PepsiCo. I'm in this class this semester, just testing the waters for next semester. I'm double majoring in computer science and stats. Oh, that's awesome. That's so good. Thank you for joining in. Good to see you here. No, we're glad to have you. Feel free to ask questions. And just my biggest advice to anyone is this: do what you like. If you are liking computer science right now, and I've had people get into business analytics and be like, I don't like this. I'm not doing this. But if you're liking computer science, if you're liking stats, keep doing it. And then look at the careers people have with those degrees and see if you like them. Do internships for those degrees. And if you're liking it, if everything's going strong, just keep on the path you're on. The more internships you can do, the more people you can meet in your field, the more seniors you can meet, the more you get acquainted with your field, the better experience you're going to have. So immerse yourself in your field. Animal science, excellent. I like animal science, and I like veterinary medicine. I don't do it, but I like it. So, yo, Brian, so yeah, good to see you here, Alex, on the VS321. Oh, yes, Alex, yes. Do you post this stuff on Reddit, Alex? Is that you? We'll do the next topic here in a second. Is that you posting the updates on Reddit? Are you that? Are you the one doing that? That is, I knew that was you. I go to Reddit all the time and I look at your updates. And thank you, Alex. So Alex makes, and are you using, because were we looking at it over this summer? Was I helping you out a little bit with the Shiny dashboard? Because did you do it through Shiny? So Alex, and so thank you, Alex, jumping in here. So if you've been on Reddit and you've seen the kind of updates, the COVID updates, that's Alex right there. Thank you, Alex. Not to out you. Google Sites and Sheets, yeah. And so you're using the Google, but I think, were you first using Shiny? But just the understanding of it and the visualizations. I wish we did more on visualizations. And it's so awesome what Google can do right there. But yeah, no, I look at it. I always look at I don't always click all of them and the numbers. I gotta stop thinking about those numbers. But no, great job, Alex, right there. And thank you so much. I'm glad the courses have helped you. And we appreciate you kind of monitoring the numbers and posting stuff for us right there. So everyone, yeah, give a round of applause for Alex right there. But Alex, I always say my students learn things and then teach me things, because right now I'm trying to learn how to program MuBot. We now have a bot in the chat, Alex. So we've updated the bot from last semester. We actually have a working bot. MuBot, you just calm down. You need to calm down, MuBot. Just chill out. But everything's good. How about we do some type 1, type 2 error? Let's give Alex some points right here. We're going to give Alex some points here. I can edit points on the fly. We're going to give Alex some points, then we're going to get started here. Healthcare is connected to living. Oh, it doesn't even have you in the system yet because you just got here. Oh, I'll update your points. Pepperoni Pizza Club. That is everyone's favorite quote. How about some type 1, type 2 error? So type 1, type 2 error. Oh, should we do something relevant? Oh, okay. Oh, relevant topic. Okay. Oh, God. Let's do a relevant topic. So here's a relevant topic. You take a flight. What would be the null hypothesis after you take a flight? And this is kind of what Australia's been doing. One of my friends is in Australia. And when you fly between provinces, I think they got territories and provinces. So, again, right there. So great job right there, Sam. When you fly to Australia, or when you fly around Australia, what do you think they have you do after you go on a flight? They've got it under control there. Not to sing the praises of Australia, but they're doing pretty well with it. I don't think they've had a single death in November. So get tested. So, and actually they have people 14-day quarantine. So let's say you have, now I'm going to write it, not going to even jinx ourselves. So no new cases. Yeah, their numbers are insane. And let's put an alternative right here. Okay. After a flight in Australia, I don't know how to spell. Brian will never learn how to spell. Never. Here is what they assume. Okay. So after a flight in Australia, here's what they assume. And I want to say this, the null is always kind of whatever you want to start out believing. So the null is something you believe without evidence. Does everyone understand that? And I've had a lot of talks with people, people say, well, the null hypothesis should be this. There's nothing the null should be. The null is just a starting belief that you do not need evidence for. So you can believe anything as a null. So always look to any question to how it states what the null is. So this is what kind of the Australian government assumes until they have evidence otherwise. Does that make sense? So they're going to assume you have it until they have evidence you don't have it. Does that make sense? So this is their starting hypothesis after you've been on a flight is they assume you have it till they have evidence you don't have it. Now, you could change it. You could easily just flip it and say, like after a flight in America. So probably this is more how we do it. So the null is you don't have it till you have evidence you do have it, like start showing symptoms or something like that. So the null is completely relative. So always look to what the null is depending on it. Do you ever tie type 1 and 2 errors into psychology? Oh, yeah. Any sort of discipline uses type 1. Great question right there, Tyler. And so now let's look at kind of type 1, type 2 error. They do this in Hawaii too. Yeah, it really depends on different successes. And we should base our, I don't know. We're not going to get into those topics. We're not going to know those topics. That's way different than what stats is. How do you determine which is the null and the alternative? The question should, good to see you here, Michael. Twas the night before Stat 201. That's what we got going on. So the null is going to be stated for you in a problem. Like, let's just change it right here and say, a teacher is a nice person. They will assume you haven't cheated until there is evidence you have. Write out the null hypothesis. And Jesse is right. Jesse, great answer right there. The question gives you the null. It's so good to have everyone here. How many people do we have right now? Write out the null. Write out the null for this. Write out the null. What is the null? We got 100 plus people watching. What? It'd be cool if it was like a random, like if I could do this every night. Who wants to like, every night we're going to practice stats. We're going to become stats experts, even when we don't have the class. So you don't have cheated. You haven't cheated. There we go. And you have cheated. Okay. There's the null. There's the alternative. And then let's say here, would you prefer? Oh, let's just do the practice. You ready? Okay. Here is what we will not get you in trouble for. Please, no teacher should get you in trouble for this if we see you doing this during an exam. So, yeah, we're here to learn. We're here to practice. In a type 1, what does this mean? Start figuring out what Brian's trying to teach you right here. If you in my class, you should know this instantaneously. In a type 1, the null is true, and we what it. In a type 1, the null is true. And that's a T right there. In a type 1, the null is true, and we what it. In a type 1 error, the null is true, and we reject it. In a type 2 error, the null is, and we. So in a type 2 error, the null is, and we what? In a type 2 error, the null is false, and we fail to reject it. Remember how you'll say the two F's right here. In a type 2, the null is false, and we fail to reject it. If you can't tell I'm making an F right here, I wish I could write on the screen. I need to get that program. For type 2, the null is false, and we fail to reject it. Nice job right there, Emily. Excellent work. It's so good to see everybody here. Thank you, everyone, for tuning in. So with the null hypothesis right here, what is a type 1 error? I want you to look at this. I want you to look right at this. I'm going to supersize here. I need like broom, 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 like Mario noises right there. I got some Mario right here. There we go. I want you to look at this. And I want you to say this is what? We're talking about a type 1 error right here. Let's say right here. Type 1 error. I want you to look at this. And I want you to say this is what? This is what? A type 1 error. This is what right here? This is a type 1 error now. You have to look at this and say this is what? This is a type 1 error. This is a type 1 error. You look at this and you say this is true. This is true. That means you have not cheated. That is a fact right there. You have not cheated. And then Sarah's right. We are going to reject that. So this was true. Let's put a true on it. So this is true. This is true. But then we are going to reject it. And we're going to say we have evidence you've cheated. So does everybody see this was true, but we rejected it? So it's true that you have not cheated, but you are falsely accused of cheating. So in a type 1 error in this instance, we rejected a true null. It is true that you have not cheated, but you are accused of cheating when you have not. And does that make sense right there? That is a type 1 error in this instance. And it'll always look like this. Null will always be true, and we will reject the true null for a type 1 error. I'll tell you why these questions have a special place in my heart in a moment. The type 2 error, the null is what? In a type 2, the null is what? In a type 2, the null is what? In a type 2 error, the null is what? The null is false. So let's put some red on this right here. The null is false, but what? We are going to fail to reject it. So we are going to fail to reject the null. So the null is false, but we're going to fail to reject the null. So I hope that makes, let me do this right here. So the null is false. So this is true, but we are going to fail to reject it. So the null is false, but we're going to fail to reject it. So the null is false, but we fail to reject it. Maybe the color coding can help a little bit right there. The null was false. You have not cheated. You have cheated. Excuse me. The null is false. You have cheated. The null is false. You have cheated. Can you give us an example with multiple choice for a question like this on the exam? I could try to think of one. Yeah. What is the symbol used for a typo? Oh, good question right there, Lainey. So here is a good way to remember the symbols. It's Mario noise. Tinkle, tinkle, tinkle. There we go there. Okay, so how do we do this right here? Mario time over. This is some good practice. A type 1 error and a type 2 error are related to alpha and beta. Type 1 I often think of as a false positive, and type 2 I think of as a false negative in the medical industry. But the way to remember this is 1, 2, A, B. Because you just count 1, 2, and then you remember the alphabet A and B. So a type 1 error is related to your alpha level. A type 2 error is related to your beta level. And beta is controlled by your alpha, your sample size, and your effect size. And those are the three things that control power. So I'll kind of branch topics right now to talk about power here briefly. Because when we talk about beta, beta is controlled by the three following things. So the three things that control beta are sample size, effect size, and I just said a second ago, alpha. And if these go up, beta goes down. And if beta goes down, 1 minus beta goes up. And this is power right here. This is power. Power is 1 minus beta. So let's just talk about this briefly right here, but we need to understand that the three things that control beta are going to also control power. So power is 1 minus beta. Does everyone understand that beta and power are just complements of each other? So when you look at this right here, you have beta is going to be your type 2 error. And basically, power is not making a type 2 error. Type 2 error. And let's see what questions are. What symbol is used? Oh, we have that right there. How do you calculate beta? You can calculate it. We don't do it in this class, and it's actually a very important thing. It's used by a lot of industries to make sure they have enough power to detect something. And literally, I heard Fauci mention it. I was going to send it out to students, but Fauci was talking about sample size, and he literally said, I want to do a Fauci impression. He sounds like an older, gravelly man. He's like, you have to have enough power when you're doing your test. So we have to make sure we have large enough sample size to detect if there's certain problems. It's a horrible Fauci impression. But he said you have to have a large enough sample size to make sure you can detect something if it's there. So he's talking about the power of the test when they're doing these clinical trials to make sure they have enough sample size to detect something if it's there. Because if they fail to detect it, what error have they made? If they fail to detect something, what error have they made? Like they're trying to look for evidence of something, and if they fail to detect it, a type 2. So Dr. Fauci was saying you need a large enough sample size to then be able to detect certain things, like if there's certain types of problems. More of a Schwarzenegger. Yeah, I know, it's pretty bad. I now I'm going to try to do Schwarzenegger and fail even worse. Maybe my Schwarzenegger sounds like Fauci. It was a horrible impression. It was the worst, top 10 worst impressions by Ryan Stevens. Probably all of them are on there. So, but does that make sense that what he's saying is if you get a large enough group of people, you can be able to detect if there's certain problems. But if you have a small group of people, you might fail to find certain problems. So if you only test the vaccine on 20 people, there might be a problem, but you wouldn't find it. Does that make sense as I say that? If you have a sample size of 20 people, there could be a problem, but you would fail to find it. It's not that the problem doesn't exist. It could be that the problem has a very small effect. like, let's say, because vaccines and stuff has side effects. We understand that there's, I mean, I'm pro-vaccine. I don't want anything. I'm not pro-vaccine, but there's certain things we should be aware of, and we need to test things out. And we need to do trials. What do you mean when you say beta goes with type 2 error? So type 2 error is literally beta. So beta is literally your type 2 error. So let's say the vaccine, topical topics I think are good to talk about. So let's say the vaccine has a very small like issue with headaches. And it's almost like, people get headaches normally, but the vaccine causes some headaches like up to a few days after, which, that's worth it for like immunity to things. But let's say there's this issue. Would that be easy to detect or hard to detect? If the vaccine has just a headache that it causes in like 3% of people for like 3 days after, would that be easy to detect or hard to detect? Would that be easy to detect or hard to detect? It'd be very hard to detect because the effect size is very small. So if the effect of what we're looking for is very small, it'd be very hard to detect, and we might make a what error. We might make a what error if we don't detect it. Like we're like, oh, there's no problems with this. We don't see any problems. And I don't think a headache's that big of a problem, but it'd be very hard to detect, and we'd probably make a what error, a type 2 error, because we'd fail to find it. We'd be like, there's no headache issues. We didn't find any. How could we possibly detect this headache issue? What could we do to make it easier to detect the headache issue? And this is the type of question we put on the exam maybe. So how could we make it easier to detect the headache issue? Increase the sample size. Yep. If there's a small effect size, you need a larger sample size because it'd be easy to detect. Like, let's say, maybe I watch the news way too much stuff on this. Let's say some of the early vaccines had major issues, like let's say neurological issues, stuff we don't want to have. Like an earlier version of the vaccine has major neurological issues. And like the vaccines are looking good right now. I'm just saying. Then when you think about this, the effect size would be very what? The effect, if there's a big issue with an early version of it, the effect size would be very what? If there's a big issue with it, the effect size would be very what? If there's a big issue, and then Meg, I'll go in more details here in a moment. It'd be, oh, don't tell me PS5s are live or something, right? Don't do that to me now. Still trying to get that PS5, PS quintuple. So the effect size would be very large, and then the probability of missing it would be very small. So, and then we'll go back and mention type 1 again. Type 1, well, we'll talk about type 1 here again in a moment here. Effect size is basically like the impact it is having. So when you think about effect size, it's actually definitionally, effect size is the difference between the null and the truth. So if you have the null being no headaches, so all we need is the null right here, is that the vaccine causes no headaches. So if only 2% of people are getting headaches, is the null true? The null is what right now? If only 2% of people from it are getting headaches, the null would be what now? 2% of people are getting headaches. The null would be what right now? The null, if 2% of people are getting headaches, the null would be what? The null would be false. Because the vaccine does cause headaches. And that's not the end of the world. But now we know that the null is false. Just we know with our like understanding that we wouldn't have for the question that the null is false. But 2% might be hard to detect, meaning that we have a very small effect size. But what if everyone who takes the vaccine gets a headache? Nothing is not going to, we're just saying, this is just all hypothetical stuff. But if everyone who took the vaccine had a headache, would that be very easy to detect? So the null is that no one gets a headache. The null is false. Everyone gets a headache. Would that be very easy to detect? That would be a high effect size because the difference between the null and the truth is very large. So if any percentage of people had headaches, then exactly. And so then the problem is the null is usually false. Like, because, like, is this really the truth? The null is usually false. Like, if you were to test enough, you could figure out the null is false. But that's usually, like, not practically significant. So like, what if I told you 1 in a million people got a headache? Well, then the null is false, but then it's not really practically significant because it's like, well, 1 in a million getting a headache, not the biggest concern, and basically zero. You could say, well, it's basically zero. The null is basically true, but the null is not actually true. But it would be very, very hard to detect that because it's such a small effect size. Now, type 1 got brought up again. Now, interestingly enough, in this headache example, what would a type 1 error be? What would a type 1 error be in this headache example about the vaccine? What would a type 1 error be? And remember, use your tricks. The null is what in a type 1 and we what? So use your tricks right here. In a type 1, the null is this and we what? So, but be very specific. Be very specific. Oh, there we go. I think Florence did the whole thing right now. Exactly. I think Florence got it. Exactly. So we would say, exactly, we would reject the null. Wait, Tao, double check. Remember, in a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. So the null is true and we reject it. So people do not get headaches, but we think they do. Victoria right there. Excellent wording right there. The null is true and we reject it. So it is true that people do not get headaches, but we reject that and we say that they do. No, don't worry, Tyler. It's so easy. I mentioned why these questions have a special place in my heart to me. My heart's over here. I made a mistake on one of these in Stat Lab and got reported to Charlie Quick. He was like, Brian, student says you don't know type 1, type 2 error. I was like, what? And so, yeah, it was my first year of teaching, and I think I made a mistake. I think I reversed it. So don't worry. It's very easy to reverse. Is this making a little more sense? Who feels like they have type 1, type 2 down a little bit? I know it's one of my favorite stories from teaching. It's like, I still remember the instructor got so mad. It was before I was a teacher, actually. I was a TA. And the instructor was like, I don't think the TAs know type 1, type 2 error. In type 2, the null is false. And we fail to reject it. We never, Gussie, good question right there. We never accept the null or accept the alternative. We only reject the null or fail to reject the null. And if we reject the null, so let me write that down right here. And then we'll do another topic. So we only reject the null and have evidence for the alternative. And or we fail to reject the null and we don't have evidence for the alternative. And we don't have evidence for the alternative. So we only reject the null and have evidence for the alternative, or fail to reject the null and don't have evidence for alternative. So we don't ever accept the null or accept the alternative. We just look at the null and say, you know, do we continue to believe the null? So some people call this retaining the null right here. I've heard people say I retain the null. So is the type 2 the one that you... Good question right there, Sam. Sam, I don't think I've mentioned that too much, but it's all contextual. So, you know, if you think from one of the earlier examples we did with cheating, when would this be worse? Who would the type 1 error be worse for? The student or the student or the teacher? So think of a type 1 error right here. And which of these would it be worse for? In a type 1 here, the null is true. And I remember the order is true, false. That's good. Amanda, good work right there. So who would this be worse for? The student or the teacher? So the null is true. You haven't cheated. This is true right here. And the teacher says you have because they reject the null. So this would definitely be worse for the student. This is getting accused of cheating when you have not. But then what would a type 2 error be worse for? Type 2 error would be worse for the teacher. Because in a type 2 error, the null is false. So this is false, which means this is true. And you're always going to believe the false thing. So in a type 2, it's worse for the teacher because a student gets away with cheating. So in a type 2, and so it's all situational. It's all situational which one's worse. So does that make sense right there? I think maybe Sam asked that. And then I think we got a few more. Let's do another topic. More topics. Everyone's going to be like, Brian kept us up too late. Working on topics. Good questions right there, Sam. Thank you so much. Good questions. And thank you everyone for asking questions in the chat. Love it. So the other one we did power. We did type 2. I see chi-squared on here. I think it's the only one. I guess we'll end with some chi-squared. So let's do a chi-squared question from kind of start to finish. So let's write a chi-squared question. Okay, what 2 variables should we collect? What don't know is Mr. No. With the thing you typed out before like that, we only making you go into greater detail. Well, with the thing you typed out before, like which was the type 1 and which was the type 2. Oh, that was just interpreting. So what I typed out here, let's put a little thing. When making conclusions on tests. This is unrelated to type 1, type 2 error. It's just whenever we reject the null or fail to reject the null, we say it this way. So when we do this, what error could we have made? It's possible here to make a what? And it's possible here to make a what? Not saying you will, but with these, which one here error could you make? If you reject the null and let's say you have evidence for your alternative, this is where you could maybe make a what error. So it's possible you made this. It's not that you did. It's possible that you made it right here. Type 1. Because this, if the null was true and you rejected it, you made a type 1. So it's possible to do that right here if the null was true. So if the null was true and you rejected it, that would be a type 1 error. And then this one right here could be a type 2. We don't know you made it if the null was false. So this one could be a type 2 error. Great questions, Meg. It's just possible that you made those errors. It's not that you could have. Like when you go back to the previous example right here, what would it mean in this context for the teacher to correctly reject the null? Can anyone explain what it means in context here to correctly reject the null? What would it mean to correctly reject the null? Just tell me, like, then this teacher did this. What does it mean to correctly reject the null right here? The teacher did what? The teacher did what? She has proven that a student cheated. She correctly accused a student of cheating. So the teacher correctly accused a student of cheating. Correctly failed to reject the null, which you could do. You could correctly fail to reject the null. So actually got accused of cheating. No! He didn't even apologize after I got the dean involved. I got an A on the file, so to him, well, good job. I'm really glad, Shakira, that you fought that, and I'm so glad that it's, I always, whenever I have to make these sort of accusations, I always come at it with kindness. I have had to go back and I have apologized to a student or two for making an accusation. It's rare. I always come in with the strongest of evidence, and it's a very not fun situation. I have had to say I'm sorry, that I apologize, and I believe I have had to do that. So I think teachers should apologize if they make errors. It's really tough. It's really tough being in this situation. And I will say this: do you think Brian errs on more type 1 or type 2 errors? What do you think Brian errors on? He tries to err on this. My policy has always been to err on what? Making more what errors? My policy is always type 2. I'm always erring on type 2. So not saying I can't make a type 1. And I hope I've never, I have had, not had enough evidence for everything to go through with student conduct. But like I bring it to them and show it to them, and then they investigate further. Like I usually consult with them before like putting everything through to the student. But they're always like, yeah, that's enough. Go ahead. And then everything starts up because it's never open and shut. It's a lot better when the student just flat out says, yeah, you got me, which I have had. I've had students just flat out say, yeah, you got me. And I'm like, okay, are you sorry? Because if you're like that quick to tell me, then yeah, but it makes it easier. It makes my life a lot easier. That is literally the least fun part of my job. And if I ever make an accusation, it doesn't come through, I do apologize. And it's rare that I have to do that, but yeah. So just don't cheat and come to class. Exactly. Can we still fill out the extra credit form? And if we had the maxed amount, do we just put in 2,000? Yeah, sure. Go ahead. Let's do a chi-squared test. Let's do a chi-squared right here. Okay. So let's go right here. Let's do the chi-squared. And thank you, everyone, for being here. Do we still have a crazy amount? I'm really just shocked. I got to post a note up here. Oh, my gosh. We got 120. What is going on? Twas the night before the exam. All through the class, the students were studying. I like it. Okay. And remember, we did drop in. Thank you so much, Nikki, right there. We did drop in the link to the playlist. I still got that right here. If you're looking for something after we finish this problem, I'm probably going to hop off. There's the link to the playlist. It's got a lot of good walking through each chapter. You're calming down for the exam. Yes. Awesome. Just don't worry. Relax. It's not weighted, like at 18%. It's not going to massively change grades, but keep working hard and we'll look to see if there's a curve afterwards. So, and really thank you everyone for all the hard work this semester. Crazy semester and lots of hard work. Let's do a chi-squared question. Let's do it. Okay. What are we going to collect data on? What are we going to collect data on? What questions? I need your help. I need to collect data on something. I need data on something. What are we going to... Let me start setting up the problem. Let me insert. Cookout. Yes. One of these days I'll go to Cookout again. One of these days. Cookout. I think there's a Cookout around us. V. Where'd that V come from? There we go. Okay. So could you type out a brief description of type 1, type 2 errors? Sure, yeah. I'll do that really quickly right here. Type 1 error. When you reject the true null. Type 2 error. When you fail to reject the false null. And take a look. Remember, the type 2 is the fail to reject the false null, and type 1 is rejecting the true null right there. 80% is kind of a lot. I know, Nick, it is. It's not as bad as some classes, but it is. I think my other classes might have a little higher percent, but I only got to get a 50 in order to keep my A. You got it, Marissa. You got this. You're welcome. Thank you so much. Well, you're welcome, Marissa. Chi-squared eats at Cookout and has Reddit account, Nick. We're doing it. So we want to investigate if Reddit really loves Cookout. We survey 200 students and ask them if they have a Reddit account and eat at Cookout regularly. Below is the contingent, wait, why can't I think of it? Contingency table. Yeah, contingency table for the data. So this table right here, let's go ahead and put in some numbers for it. Let me make some more spaces right here. So this is going to be our data for the problem. And what do we notice right here? What kind of question are we dealing with? How many questions on the exam are not multiple choice true false? Maybe half-ish? Maybe half? That's a guess, Patrick. Sorry, I don't know off the top of my head. About half-ish, about half. What do you notice about this problem the way it's written? What do you notice about this problem the way it's written that immediately has you identify its chi-squared, which is kind of a tools and techniques question now also. What do you notice about like people who eat at Reddit? It's categorical, which means we pass the condition of count data. Now, I should put in here technically 200 random students. So condition, we got to do it. Condition 1, what's condition 1 right here? Condition 1 is what? Nos gatos. What do we have right here? 2 cats. There, I get it right there. What do we have right here? It's random. So we've randomly selected, and we're doing UT students, so I can't because they get Monster Cat hits me with a copyright if I do. One time I played it too long. So with this right here, we have then what is the condition 2? Condition 2 is what? Condition 1 is random. I think it's close to that, clarified. I think it's very close to that. I think you're right. Condition 2 is what? Oh, what's condition 2? Condition 1 is random. We randomly select 10%. And what does 10% mean? You must sample less than 10% of the total population. Nice job right there, Sam. Yep. Condition 2 is less than 10%. We did a big thing on conditions yesterday also. Condition 3, we pause. Make sure to pause right here. And we ask, what kind of data are we dealing with? Now, condition 3, great job right there, Victoria. We need to recognize that this is categorical data, and we'll do a check right here. So let's go with Cookout, yes, no, Reddit, yes, no, and we'll go right here and have 40 students liking Cookout and 30, 10, 160. And then right here, Cookout, yes, and then let's go right here and go, there we go. This needs to be, let's go here. Cookout, yes, will be, this needs to be 200. And the no across. So if we go right here, let's go 60. Sure. And then this needs to be 100. Okay. So that's 130 and that's 70. There we go. Okay, so these are the actual. Can you make one of those lists for the third test due for each problem? I think we have that in the last video. So you see almost the same numbers. So here are, so Gussie, are you asking about all the conditions? And we know it's the chi-square because it's 2 categorical variables. Nice job right there, Lainey. 2 categorical variables, so it's the chi-squared test of independence. And we have a contingency table. If you see the contingency table, then you are doing the chi-squared test of independence. Like we are doing the chi-squared test of independence. But what third test to do, or what third condition? So the third condition is dependent on what kind of data we're dealing with. And so it's in yesterday's video. And I think someone was posting a link to it earlier. I can post the link here at the end again if you remind me. And we went and we did each one. So check out that video from yesterday, and we do each condition for each test, and then we show what the third one is. And so what is the third condition here? What is the third? And I think Lainey already said it earlier. You're welcome, Gussie. Great question right there. What is the third condition right here? Gussie already said it. Expected cell count means each count must have at least 5. So each count or each expected count must have at least 5. So this is the actuals or the observed. So this is the observed values right here. These are the observed values, and these are the expecteds. The expected is going to be row total times column total over grand total. So this is how we get the expecteds right here. Row total times column total over grand total. Can you write out the conditions? Yeah. So the conditions for this one is going to be condition 1, random, less than 10%. Condition 3 is expected cell counts greater than 5. And condition 4 is, is count data. So these are the conditions right here. Thank you so much, Peyton, right there. Peyton dropping the links for us right here, and you can go through and see it all. And thank you so much, Peyton. Everyone helping out. Vols help Vols. Even Mubot knows that. Peyton, you are the hero of tonight, hero of eternity. So here's the conditions for the chi-squared test of independence. You know what? I think, you know what? Let's do this. This is a short offhand, oh my gosh, independence. Close enough. So every test has this right here. And in order, 1 proportion Z test. And then let's grab this. And go right, do not look further down the screen. Success, failure. And we did one of these for each one. And then sampling distribution of sample mean. Large enough N. 1 sample t-test. Nearly normal. And there we go. And let's go 2 sample. And independent means. There we go. I think that's got it. Let's zoom out a little bit here. And oof, that's way too much. So here are all the ones right here, the 1 proportion Z test, and these work for confidence intervals too. Yeah, it starts Jan 20th. Yep. Inauguration day, Jan 20th. Start of the classes. That is when everything starts up. Sampling distribution of the sample mean, 1 sample t-test, 2 sample t-test, and chi-squared test of independence right here. Here is a kind of shorthand of all the tests. Does this make sense to everybody right here? Here is all the tests right here, or all the different things. Is everyone good on this? I think we're good. So how do we do the expected cell count right here? Can anyone tell me which expected cell count we're going to focus in on the most right here? Which expected cell count are we going to focus in on? I wish I had, there's a reason we'll focus in on one of these. Which one will we focus in on? Will it be this one, 1, 2, 3, or 4? We'll focus in on the no, yes. 3, correct. 3. And the reason, and great job right there, Lainey, excellent work. We're not focusing in on it because of this. It's just coincidental that it has the lowest count, which kind of happens every so often. Yep, and this formula right here will be on the exam sheet, the row total times column total over grand total. So that stands for row total times column total over grand total. And the way I like to do it is literally circling the row total, circling the column total, multiplying those together, and dividing by the grand total. So this will get you the expected cell count for that cell. So this will be 40 times 70. Let's show it here on the main screen. So nice job. Thank you so much. People got in the chat right there for me. 40 times 70. Excellent work. It's 14. And there's a trick now. Interestingly enough, I found this out a long time ago. that once you figure out that this is 14, well, then this one has to be 26, and this one has to be 46, and this one right here has to be 114. So they all actually have to add up to their respective totals, and I think I've done it. Oh, wait. Got one off. Someone correct me here. I think this is 104. Is that correct? Oh, no, I think I did something wrong. I think I got something wrong. What is wrong right here? This one's wrong over here, right? Oh, that should be 56. This should be 56. I'm cheating by doing it this way. And yep, that's right. So someone correct me if I'm right here. Can you go over why HA could be one-sided or two-sided? Yeah, we can do it here, Stephen, right after this one. Yep, we can do that. And so these are the expected cell counts. Like Sudoku, exactly. That's the way I view it too, Victoria. That as soon as you find one of these, and you know what's really interesting? Brian, this is a what by what. Brian, this matrix right now is a what by what matrix, which is really interesting about it. Brian, this is a what by what matrix. It's a 2 by 2 and has 1 degree of freedom. And it can be anyone as soon as you find one of them. The other ones are forced choices. So that's, once I put in the one number, they were all forced choice decide after that. So there's 1 degree of freedom, a 2 by 2. The degrees of freedom are rows minus 1 times columns minus 1. So you just say, Brian, that's a 2 by 2. Reduce the rows and the columns by 1, and you get 1 degree of freedom. The cell chi-squared, you can't solve that way, though. You can't solve for 1 cell chi-squared. So technically, I might cheat in a moment to solve this problem, as we can look at some jump output too for it. Yeah, let me do some real quick. 2 seconds, because I've got things open in jump. Close down that. Go here. And we'll just close it out. Cool. Okay, let me open up a new jump spreadsheet. And there we go. Okay, we'll get a problem here in a second. And so there we go. And so with this right here, what would be the formula for the chi-squareds? Chi-squared is going to be observed minus expected squared over expected. So what is the chi-squared for this cell right here? I think I know what it is. A little bigger than 1. It's about 1.11. Is it 1.1111? No, it's something close to that. Off the top of it, speaking of jump, would you say that after this class we could put using jump on our resume? Yeah, I would totally do it. I would totally put like statistical software, jump software. I think it's good to show what you're doing. And yeah, I'd totally do that. Can you explain how you got the numbers for the second 4 by using 4 again? Which, Griffin, go into a little more. Which 4? Are you talking about these cells right here? With these cells, I basically found the ones that added up to these totals. So that's just kind of a trick right there. I could have mathematically found all of these, but I found what added up to the totals. So does that make sense right there? And it should be positive. It should be positive, 1.143, and that makes sense. We're just going to plug in whatever the observed is minus the expected. We're going to square that, and it'll always be a positive number because it's chi-squared. So it's going to be observed minus expected squared over expected. And people are saying it's 1.14. Oh, no problem, Griffin. Ask all the questions. You guys know that's what we're all about right here. Asking questions, answering questions. I really appreciate it. There we go. That is the chi-squared. Nice job right there, Victoria, on the extra decimals. So that is a chi-squared. So what do we need to find? We need to find all the chi-squareds. Okay, so degrees of freedom is number of rows. Exactly, yep. The way to think of degrees of freedom is if you were to ask people, like whether they are freshman, sophomore, junior, or senior, and then you ask them if they own an animal, how many degrees of freedom would there be here? Freshman, sophomore, junior, senior. How many degrees of freedom would there be here? You're asking, do you own a dog? Yes or no? And freshman, sophomore, junior, senior. So it'd be that. You can also just kind of visually delete off a row and a column, and you can see that there are 3 degrees of freedom. So I always, have people say, Brian, this is a 2 by 4. And since it's a 2 by 4, reduce it down to a 1 times 3, and there's 3 degrees of freedom. So the degrees of freedom will be this right here. Brian, since it's a 2 by 4, reduce it down to a 3 by 1, and there's 3 degrees of freedom. So just kind of some good practice right there on how to get the degrees of freedom like instantaneous on this one. So we're going to take our numbers right here. We're going to put it into jump because it's going to make life way easier. So this is how we input it. We just make the screen go haywire is what we do. To put it into jump, we go right here and we go to cookout. And cookout gets yes, yes, no, no. And then we go right here to Reddit. Reddit needs to permutate the other way. Yes, no, yes, no. And so yes, yes is going to be, we're going to put frequency right here. Doesn't matter if we name it, but I like to. And frequency is going to be 30. And then this is cookout yes. There's that one. And then this is no yes. And it's cookout no. And Reddit yes. And then this is no, no. Cool. We're going to go to here to analyze, fit y by x. We're going to put in, does Reddit explain if somebody eats a cookout and frequency? And here's our graphic. Not that big of a difference. Let's see if we got our numbers right. So we should see the 14, all those good numbers here. Here's our expecteds. There's the 14 expected right there. Did it do it the same way? That's really cool. So, and here's the cell chi-squared. There's our 1.14. Now, what do we do with all of these numbers right here? You know what? Let's take this. Since we should be able to use the jump during the test, will you have any mathematical questions for chi-squared? You could. What you could get is, here's a question. This question could say right here, what is the chi-squared test value for this test? So it could say, what is the chi-squared test statistic for this test? What is the chi-squared test statistic for this test? Take a moment and see if you can figure out the chi-squared test statistic. I've got a good estimate in my head. Take a moment and see if you can figure out the chi-squared test statistic for this test. Who knows what the chi-squared test statistic would be for this test? Florence, you're on the right track. Florence, you got it. It's got 1 degree of freedom. What is the chi-squared test statistic, though? So the chi-squared test statistic is the sum of all the cell chi-squareds. So there we go, 2.198. Yeah, exactly. That's whatever the sum of all those numbers are right there. So let's give it a look on the output in jump. And what do we see right here? We see 2.198. And this is going to be where your p-value is. Remember this little thing right here. The Pearson has your p-value. The Pearson has your p-value. We're doing the Pearson chi-squared test of independence. So don't look at the likelihood ratio. We don't do that test here. We don't do that here. And the Pearson has your p-value. So the Pearson chi-squared test of independence is where your p-value is. So one thing we didn't do for this test, which we should have done, is we should write out the null and the alternative. Now, the easiest way to write out the null and the alternative is literally to put right here, independent. If I could write better. One of these days I'll learn how to write. But independent. You know what we're going to do? We're going to insert word box. But someone go ahead and write the null and the alternative in the chat right now. But we're going to go insert word box. We're going to write independent. And this is going to look way better here. Because we're going to go right here. We're going to take this. Someone would be writing the null and alternative in the chat right now for practice. All this practice. So we're going to go grab this. We're going to move it so that it's be able to go behind it. Did that do it? Nope. I never know which one does what. I know the pictures like show you. That's behind it. I'm a fool. There we go. I should just look at the pictures. And we just go right here like that. And let's make it bigger. Really? There we go. Perfect. Love it. There we go. So how do you get the expected values? I think I missed that. And so when you get the expected values, I'll show again how to get an expected value. It's row total times column total over grand total. So the expected value, I can't erase on it now, I think because it's like behind it or something. Oh, I can. Is going to be a row total times a column total over a grand total. So this right here, this formula will equal to 14. Kind of look at how it zeroes in on this. It zeroes in on that cell. And that is how we get the expected value right there. So that's the second number, which is the expected, if you can't tell right there. So that's the expected value, is the second one on there. Does that make sense? And Reddit is independent of cookout, exactly. Or using Reddit is independent of somebody eating a cookout. How do you know the observed values? We generally give those. So the observed values are just how many people were in each group. That's what an observed value is. Just how many people were in each group. And so what other last questions are there? I think someone had another question about, I don't remember what the other question was. Go here for another few minutes here. What other last questions are there? Thank you so much, everyone, for tuning in. Check out those other playlists because we did the chi-squared right here. Really good reviews tonight. But use 130. Wait, 130? Was it Shakira? Would you... No, we wouldn't have you work backs from expected. That's a little too mathy. Why do you not look at the top rows? Oh, we do. Well, you can look at the top row. The top row right now, at least the way it's organized, is the counts. This is how many people there actually were from the start of the problem. And we kind of worked it from scratch, and then we put it into jump to solve it. These are the observed. So those are the observed values right there. Can you go over why HA could be one side? Oh, yeah, Steven, thank you. That was, yeah, I forgot you had that question. That did make sense for the expected value. You're welcome, Christian. Good job right there. What videos should I watch to best review for the test? I really think, did I put the playlist in here again? Let me drop the playlist one more time. Like, it's, I know everyone crams, but like, always, here's Brian's tips for tests. I'll always start kind of a week early reviewing for a test and do it in little bits. Where's my soundboard? You know what's coming right here. Here we go. I'll do it in little bits right there. Always study for tests in little bits. Try to do it in 1 hour chunks and then change what you're doing every hour. So for the future, don't worry, we're in crunch time now. But in the future, always study in what? Little bits. That's what we do right there. So little bits of studying. Don't ever just like, I'm going to study it all today. No, be like, okay, little bits, little bits. So day early studying, week early studying, whatever you can do to study early. The question was, when is it going to be one-sided, two-sided? So good question right there. Let's put 3 questions on the board. Let's do this. Let's play some music right here. Some mega nuts punch out. Let's do this. Okay. So UT wants to see. Da-da-da. Okay, there we go right there. Yeah, Canvas content quizzes are huge and the Kahoots are huge. So watch the last Kahoot, the Canvas content quizzes, all that great stuff right there. Great advice, Victoria, right there. And you know, a lot of people have done very well in this class. So, and it was Andrew asking, is the practice test a good review to see if we know the material? I think the Canvas contents, because they literally have questions that are on the test, are really great. And the Kahoot goes over Canvas content. And also we've been hearing great things about, so big shout out to, I think it's Alyssa, amazing work, Alyssa. So everyone just give some props to Alyssa right there, who's been our SI leader. Just really want to say a big thank you to her for all the work she's been doing this semester. We're so lucky to have an SI leader and so lucky to have an amazing SI leader. So supplemental instruction by Alyssa. So if you've gotten some help from her this semester, tell her big thank you and we appreciate her. So what do we have right here? Some kind of basic tests. And how do we know if the alternative is one-sided or two-sided? How do we know if the alternative is one-sided or two-sided? We always look to the question itself for the way the alternative is. Just 9 and 10. Great question right there, Delaney. Just 9 and 10. Just 9 and 10. So we just look to see here the wording of the test. Does anyone have any idea on any of these to see which way they are sided? Which way are these sided? Are these... Which way do these go? Which way do any of these tests go? And then I think, yep, this is going to be a greater than test right here. So the above wording right here indicates to us that we're doing the greater than test. And then the 2 is going to see, we're going to see if under. So that's going to be wording that indicates the less than alternative. And then this one right here is going to be a two-sided because we give there's no strong wording. They're basically saying if we're seeing if it's equal to this. So it'll be equal to this or not equal to this. Great job right there, Victoria. You're like one of our top Kahoot players. I love it. Love it that people can see and be like, okay, just identify with the wording. If it's talking about less than this, greater than this, and look for what the researcher's trying to do. Yeah, no, it's Stephen, great questions. And then the more you see it, the more you practice it, just the better you can get with it and identifying, just the different things. So one thing we can do branching this topic is we can look at these alternatives and do a drawing right here real quick. Roll final will be it's not rounded. I do the bonus. Great question right there, Hannah. The final grade I do the bonus on, and the grades are what they are. So work hard. You got this. Class is almost over. Class is almost over. And so, okay. So here's your greater than test. Here's your less than test. And here's your does not equals test. So with the greater than test, put greater than right here, less than, and not equal to. So let's say the p-value right here is 0.02. So can anyone tell me the remaining p-values? I messed that one up, sorry. And that looks like it's more than it is. What are the remaining p-values right here? What are the remaining p-values? You should know final grade pretty soon, because once everything's graded on Canvas. Tyler, you had an extra 0, you had an extra 0. Is it possible to have a greater than 100 on our final grade once you add up the points? I think it is. I think there's some people who are right there. I think there's some people right there, and I'm really impressed that some people are. It's possible if you get all the bonus. And I know I'm hoping. I've seen it. It's super rare. It's super rare, but I've been really impressed. And I've seen some people get over 100, and I've definitely written them letters of recommendation being like, this person achieved over 100 in our class, which I rarely see. And I teach, I'd say it happens about 1 in 500 students. Happens in, I think my one student in 207 who got over 100, and then he went on to the really crazy job, and he had all straight A's at UT his whole time. I was like, wait, so you made straight A's this semester? He's like, I made straight A's every semester. I'm like, he's a really nice guy. He's not arrogant. Arrogant is when you think you're more than smarter than you are, but yeah, he's a smart guy. Will the exam be more math questions than conceptual? Kind of a mix of both math and conceptual questions. And I think, do people see the concept right here? I hope it's, I'll take You got this, Tyler. You got this, Tyler. You got this. I got faith in you, man. You got this, man. You got this, Thor. So I'll be sending you that video. Don't worry about it. I'll be sending you special intro. So we got it. So what do we have right here? We have 2% is this area right here. We have 98% is the area below it, because these two add up to 1. And then this right here is doubling it. So you see how it's kind of mirror reflection of it right here. I want the link to your first session. Yes, Tyler. And I'm more than happy if people want to come on. This is something I've already talked to 320 students about. But if we want to have like special guests, and if people want to appear on camera, like I can zoom you in like we did with Julio. And if you want to give some words of advice, like if anyone wants to come in and give words of advice to 201 students for next semester and be like, hey, you can appear just by voice, or you could appear on camera. Your call. If you want to do it, it would be on YouTube. So just realize that. If you like, I don't want to appear on camera. But if you want to come in and talk to 201 students and give them advice and be like, hey, do this and you'll make an A. I think students listen to students more than they listen to me, and they should, because they're the ones getting the A's. I don't get A's in my class. I can think what you should do to get an A. That'd be awesome. Yeah, that'd be awesome. You're always welcome to do it. Is the grade on Canvas accurate? Yep, the grade on Canvas calculates what the category percentage is. Yeah, you're more than welcome to, Victoria, Tyler, and tell Andrew too. Are the extra points added on to final grade? Not yet. So I'll add those on at the end. I add those on at the very, very end. I usually put in the final letter grade, and usually do realize that it's 2 points, so it's really generous. So you could get really, really close, and some people are very close to the next grade level and just don't get it. It's a very generous bonus to the grade, and once it's on, it's what it is. And you'll see, I'll usually post like final grade letter, and so wait till I post final grade letter, and then I'll say like your final grade letter's posted. So I usually post final grade letter after that right there. And like some people get really close. It's kind of sad, but yes. Kylie, great job right there. My grade tab has a 0 for 100 for the makeup. Oh, it does have a 0? As long as that's, Marissa, you should be okay. I never look at grades on stream. I don't know why it has, maybe it's just default for that. But anyone, if you didn't take the makeup test, don't worry about it. Are we still able to fill out the extra credit form? Yep, go fill it out. Go fill out the extra credit form. Steven, excellent work. Congrats, everybody. I'm going to head off here in 4 minutes. We need sad music. I love my sad music. Oh, that's Price is Right. No. We don't want Price is Right music. Do you get credit for coming to this class? Sure, you can get credit for coming to this one right here. Ariana, excellent work. Excellent work, Ariana. Good to have you here. Price is Right is such a long song. I need to remove it. Wait, could I do that? Price is Right is off the board. Now it's not playing. Oh, man. I know. We might try to do some other stuff. Swing by anytime. Michael, you're welcome. We're going to play it again. I'm going to try and make a video with it. We just haven't had time to cut my hair. It just keeps growing. I know. I need to, like, make a video with the mullet. It's like, I know. I've got, like, what is my haircut now? What is going on with this? I used to wear it like this. I have no idea. This is crazy here. Do you have any recommendations for where to find comprehensive chapter reviews? Yeah, I've got the. You're welcome, Emily. You're welcome. I should do that. I know I wanted to do that. I really wanted to do Joker again for Halloween. I would suggest using. Oh, I know. Do I not have all the videos? Where's my chapter review playlist? Here we go. Playlist. So chapter review. I can't spell. What? I'm not finding it. Oh, because I haven't loaded. Let me show the chapter review playlist. All chapter review. Okay. So here is all chapter review, starting with sampling distribution. This is a rather long playlist. I would not suggest, not suggested, not focused enough. You're welcome, Wyatt. Good to have you here. You're welcome, man. I appreciate it. Thank you. All the positivity. That's what we work off of. You're welcome, Ian. You're welcome, Sam. Have a good break. Have a good night, everybody. Excellent stuff. They didn't seem to line up exactly with stuff on the website. Which things, Ian? Which things is Ian asked about? I might have missed it, Ian. You might have to repeat. Watch a Brad. Oh, I think my fiance watches him. We should watch that. Hopefully he has a video on like how to cut a guy's hair. You're welcome, Peyton. And so we just got Ian's video right there. Can you tell my teacher I come on? Oh man. I could try, I guess. I could try. You're welcome, Michaela. Might play sad music here in a second. Like the second concept lift. Can you do an example question over? Yeah, we'll do an example business analytics question for Jocelyn right here real quick. Okay. During the Stat to 1 business analytics lecture, we talked about how basketball teams are recruiting players with analytics. True/false? What does everyone think right here? ZMD. Cracking me up. So, would you learn Python or R first? I'd learn. I like R, but I know Python's really big. If you're doing computing in business analytics here at UT, I'd learn R. Either's fine, but it was baseball. Yep, it was about baseball teams. So this one's false right here. We talked about. Oh wait. We talked about how Walmart understands its customers a little too well. You're welcome, Patrick. Play sad music here in a second. Oh, that will not be a test question. Target. Yep, it was Target we talked about. Target with their predictive analytics. And I guess it's a little prescriptive. So they make predictions about if someone's pregnant or not. And this would be false right here. So this would be false. Both these were false that I gave. But I think that's got it. I'm going to answer some more emails, look at the Discord down there. But big thing, we just got to say it. Vols help Vols. Vol means all. Vols help all. That's what we like to say here. So keep helping each other out. Keep working hard. Remember, support each other. Vol Nation, Stat Nation. I'm excited. Yes, Noah, I'm so excited too. And we're going to keep growing. Join the Discord if you haven't. You're welcome, Shakira. Oh, man, we need some Mega Mondays right here. Let's end. What do we got to end with? I don't know. Man, it's aw. Yes, Brian, that is awesome. I totally agree. And we spell it correctly. God, we got it here. Was not the wrong screen? I don't even know where my screens are at. Well, we're going to end with the sad music because, once again, I want to give a shout out to Josiah Wilkinson. Josiah Wilkinson, one of my favorite pianists on YouTube. Thank you so much, Taylor. I'm so glad to hear that. Thank you very much for so much of the positivity. I'm going to get out here before you guys make me blush too much. play the sad music. We're in with the Stat Nation outro. This is one of my favorite short videos that I've made. But you're welcome, Gussie and Victoria. With that, Josiah Wilkinson, play us out. And I will see everyone again soon. Don't be a stranger. Bye, everybody. Bye for now. Bye.